Hey, it's great to have you here. If you can spare 8 minutes to watch this video, I'll help you improve your exam question answers by helping you to understand a key biological topic. Imagine you're in an exam and you get this question: explain what a negative feedback system is and give an example from the human body. In this video, I'll show you 4 different examples of negative feedback within the human body so that you can write about them in exams. We'll also look at what a negative feedback system is by using a very simple example. So let's get started. If you're new here, welcome to BioSmash. I'm Jo and I'm a science teacher. It might be helpful to remember that negative feedback is about keeping things the same. I thought it might be helpful to start with a really simple example of negative feedback to help you understand the key ideas. Imagine a classroom. The children are all working, but they're chatting as they work. The level of noise in the room slowly increases until the teacher cannot concentrate anymore. Suddenly, the teacher demands quiet. The children stop talking and the level of noise in the room falls. The teacher has an idea of the ideal noise level for his classroom. Sometimes the children are chatty and you can notice that the noise inside the room gets louder. Eventually, the noise level gets so high that the teacher shouts. And the shouting triggers the children to talk much more quietly so that the noise level falls. In this example, you can see that there is an ideal level, and when a factor such as the noise increases above the ideal level, it triggers an action, such as a teacher shouting, and this action causes the level to fall again back down to the ideal level. We call this a negative feedback loop. This is because a change in a level triggers an action that reverses the change. So, if we want a definition of negative feedback, we could say negative feedback is a process in which a change of parameter brings about the reversal of that change so that the parameter is kept fairly constant. A parameter is just a factor that you measure. In our case, it was noise level. Now that we understand our basic example of negative feedback, let's look at an example from the human body. So, our first example of negative feedback looks at what happens if your body temperature starts to get too high. You may know that human body temperature needs to stay pretty constant at around 37 degrees C. One reason for that is that our enzymes don't work as well at higher or lower temperatures. Check out this video if you want to know more. Sometimes our body temperature increases above 37 degrees C. This could be because you're in a very hot environment, or because you're exercising and generating lots of heat energy. Your body needs to respond to the temperature increase, and your body responds by sweating. So, in response to the temperature increase, we produce sweat. When we sweat, our sweat glands release water onto our skin. This water is heated using heat from our body, and this heat causes the water to evaporate, and as the sweat evaporates, it takes the heat energy with it away from our body. So when we sweat, our body temperature decreases. So now you've got another example of a negative feedback loop. So here's a sentence to describe it all. As body temperature increases, sweat glands release sweat. Energy is transferred when sweat evaporates and body temperature decreases. We call the part of the body that responds to the change an effector. In our case, the sweat gland is the effector. Give this video a thumbs up if you're starting to understand this topic better. Our second example of negative feedback looks at the opposite pathway when body temperature falls too low. A negative feedback loop is also activated if our body temperature falls too low. For example, if we find ourselves in a very cold environment with incorrect clothing, our body temperature starts to decrease. Our body responds to the cold by shivering. Let's add this action to our negative feedback loop. When we shiver, our muscles are making lots of contractions, and this generates heat energy. So because shivering generates heat energy, it causes our temperature to increase again. So here's another example of a negative feedback loop. So here's a sentence to describe this. As body temperature decreases, muscles contract spontaneously, causing shivering. Heat is generated through respiration, and body temperature increases. In this example, our muscles are the effectors. If you're finding this video helpful, it might be good to click subscribe. It'll help you find my other videos. Our next example of negative feedback is looking at the concentration of glucose in the blood and what happens if it's too high. Another level in your body that needs to stay fairly constant is your blood glucose concentration. One of the reasons for this is a process called osmosis, and I've got a video all about it, so I'll link it below. When you eat carbohydrates, your body breaks them down. Carbohydrates are broken down by enzymes, and enzymes break the carbohydrates into sugars. This means that after eating carbohydrates, your blood glucose concentration is likely to increase. When the blood glucose concentration gets too high, an organ called the pancreas responds. The pancreas releases a hormone called insulin. So let's add this to our negative feedback loop. Insulin travels through the blood to the liver and muscles. Cells of the liver and muscles contain little receptors that fit to insulin. So when insulin binds to these receptors, it triggers the liver and muscle cells to absorb the glucose. And the glucose is converted into a molecule called glycogen, and glycogen can be stored in the liver and muscles. Hopefully, you can now complete our negative feedback loop. So, as insulin is released, blood glucose level starts to fall, and this is because some of the glucose is absorbed from the bloodstream. If you want a sentence to describe this process, you could write, as blood glucose concentration increases, the pancreas secretes insulin. Glucose is absorbed by the liver, and blood glucose concentration decreases. And in this negative feedback loop, the effector is a gland, it's the pancreas that secretes insulin. If you're finding this video helpful, I'd love to hear from you, particularly if you have any requests for future videos. And our final example of negative feedback in the body is what happens if your blood glucose level falls too low. The concentration of glucose in your blood can also fall too low. For example, if you're jogging, you will need more energy, so you'll carry out more respiration and use up more glucose. This means that your blood glucose concentration starts to fall because there's less glucose in your blood. This time, your body responds by your pancreas releasing a different hormone. This hormone is called glucagon, and glucagon tells the liver to break down glycogen and release glucose back into the blood, causing blood glucose concentration to rise again. I've made a video that describes the process of controlling blood glucose level in much more detail, so you might like to check it out. I'll put the link below. Hopefully, you can now give 4 different examples of negative feedback within the body. I thought we'd finish off by looking at a few key phrases that you can use when you're describing negative feedback loops. The factor that triggers the negative feedback loop is called the stimulus. So the stimulus could be that the room that you're in gets colder, or the stimulus could be that you're doing lots of exercise, which causes your blood glucose concentration to fall. The action that your body does in response to the stimulus is called the response. So a response could be that your body starts shivering. Or the response could be that you start sweating, and the response is carried out by an effector. If you've been very observant, you might have noticed a bit of a pattern. Effectors are always muscles or glands. So muscles contract when you're shivering, and glands release things like sweat or hormones. Receptors and effectors are important for the nervous system. The nervous system coordinates several negative feedback loops. I've made a video all about the nervous system, so I'll link that below. Well done for reaching this point in the video. If you'd like some more help with this topic, then check out this video next. Otherwise, YouTube has chosen this one just for you. I hope to see you again soon.